Let's balance a chemical reaction that's a little bit more complicated. Now, this is going to be a chemical reaction between a compound and an element. The compound being ethylene, which is just C2H4, and oxygen O2. This is a combustion reaction, but we'll talk more about that in later videos. So let me just write. Remember, you have to always write the symbols instead of the name whenever you're doing writing a chemical reaction. C2H4, this is the symbol for ethylene. And ethylene is usually a gas, so I'm just going to put gas. And also, you usually know if a compound or element is going to be a gas. Well, in this case, we're going to be talking about compounds for whether they're going to be gases or not. If it's a molecular compound, they're usually gases. So right now, this is a molecular compound because it's two nonmetals. Again, there are exceptions to everything, but that's what I'm going to say for now. Again, we just put the add to say that these two. This is going to add with the compound to create a product, or products in this case. And then O2. Again, remember that O2, well, oxygen is a nonmetal, so it's going to have that 2 subscript. And oxygen, again, being a nonmetal, is going to be a gas. Now, for the reactants, so look, C and O. C2 plus O2. Think of it like this. That would just be CO2. Because you're basically combining the C and the O. And then to combine the H and the O, that would just be H2O. This is going to make more sense if in a later videos when I talk about combustion reactions and synthesis reactions, but you shouldn't worry about that just yet. And in this case, it's going to be a gas. And CO2 is typically a gas, and H2O could be a liquid or a gas, but in this case, it's a gas, because where would the liquid come from if these two are gases, right? So let's balance this. Now look, the subscript that you have for C, so carbon, is C2. But here, the subscript for carbon is just 1. So we have to add a 2 in front of this to get 2 moles. But then you see, what does that do to the number of oxygen? Like, the number of oxygen here. So this is 2, right? But then you multiply this 2 by oxygen. So it'd be 2 times 2, which is going to be 4. So there's 4 moles of oxygen now, right? But we won't worry about that just yet. Just keep that in mind. Because look, first we are going to have to match up like that, and then match up like the hydrogen and the carbon, and then we'll do the oxygen last. So this is H4, so it's, it's hydrogen, and then it has a subscript of 4 right here. This is hydrogen, like the reactant has hydrogen with a subscript of 2. So because it's just 2, we're going to have to add 2, because 2 times 2 would be 4, which would make this equal to this. Now, because we only have just oxygen here with the subscript of 2, let's see what oxygen is here with the subscript of 2. Now you have to add these, but I'll tell you more about that right now. So now this, because if you have this 2, you multiply that by oxygen, right? You don't have to write it down. It's just like inferred. It'd be O2 now, right? So it's going to be those 2 moles of oxygen. But here, it's going to be, this subscript of oxygen, which is 2, times 2, which is 4. So what is, 4 moles of oxygen plus 2 moles of oxygen? That's 6 moles of oxygen. But here we just have O2, right? So we have to match just these 2 moles of oxygen with 6 moles of oxygen. So what would we have to put in front of O2 in order to make it 6 moles of oxygen? It has to be a number. Sorry, I'm just going to put this right here to make more space for it. It's going to have to be 3, because what is 3 times 2? It's 6 moles. So that's a little bit more of a complicated problem, but now let's balance a chemical reaction between 2 compounds, one being sodium nitrate, NaNO3, and lead oxide, which is PbO. I mean, it can be anything, but if we're assuming that lead has a 2+ charge, then it'd be PbO. So first of all, write down the compounds' formulas, like the reactants compounds. So NaNO3. And then this could just be, we're going to make this a solid. It doesn't have to be. Oh, sorry, my camera went out of frame. And just to add it to PbO, which I'm going to just say is a solid to make this problem a little bit easier. And then we're going to make that arrow to show where our reactants are going to be. So this is a double replacement reaction, which, again, you might not know, but it just means that it's going to switch. Like, instead of Na being with NO3 combined, it'd be Na and then O, and then NO3 is going to be combined with PB. Like it's going to switch. You know what I'm saying? So to start this off, I'm going to write PB, because we're just combining them sort of. PB, and then NO3, 2. And if you don't know why I'm doing that, I'm going to explain that in a second. And then NaO, which would be solids as well, if those other two are solids. All right, so you're probably wondering why this is what it is. Okay, well look, PB in this case, we can tell from here that PB has a 2+ charge. It doesn't have to be because it's a transition metal, so it could be like a 1+ charge, etc., right? But because we know that oxygen has a 2- charge, and because PB and oxygen here are like, they're balanced, meaning they both have the same subscript, we know PB in this case has a 2+ charge. While nitrate, because that's what it's going to combine with, NO3 has a 1- charge. So these two are going to switch, but like obviously this 1- is just going to be a 1, and we're not going to even write that down because it's just inferred. So we don't have to write down the 1, but it's going to be PB NO3, remember, 2. Well, this would just be 1. Again, it's inferred. You usually put brackets around like the compound if you're mixing an element in a compound, so that's why that is. While here, because we're doing Na and O, NaO. Ooh, forgot to put this too. It's really important, by the way. All right, so oxygen has a 2- charge. Na has a 1+ charge because it's an alkaline metal, right? So they're going to switch, but again, it's going to be a +2 instead of a negative because subscripts cannot be negative. Na2O. That's why that's what that is. So let's think about how are we going to balance this. Is to do the biggest components and like balance those out first, and then I get into the nitty-gritties, like, you know, the oxygens, etc., etc. So look, because NO3 has a subscript 2, we just like multiply whatever that subscript is with the subscripts that are inside of this bracket for this compound. So it'd just be O subscript 3 times 2, which is oxygen 6, so 6 moles of oxygen, and this nitrogen has a 1. Again, you don't write down the 1, it's just inferred. Because that nitrogen is 1, and we gotta multiply it by a subscript of 2, it's gonna be 2 moles of nitrogen instead, so N2. But here, it's just NO3, it's just 3 moles of oxygen, and then this N has just 1 mole of nitrogen, right? So because of that, we're just gonna match these up and put 2 in front of this. Boom. So these two are equal, we know. But now look at Na. We added 2 moles to Na. Na already has that here for the products, which means that they're also balanced. Now oxygen, this is also matched up with this, and PB is also just one subscript on, you know, for the reactants and also for the products. So that's why that is what it is. So it's all balanced. And again, you can count like how many oxygens there are and see if it's equal. And by that I mean you could be like, okay, so here there's 6 moles of oxygen. We just multiply the subscript 3 times the 2 right there in front of everything, the coefficient of 2. And then we also add with this like 1 mole of oxygen, and it would be just 7 moles of oxygen. While here we just have to do this oxygen with subscript 3 times 2, the subscript 2, which would be 6 moles of oxygen, plus 1 mole of oxygen right here, which would be 7 moles of oxygen. So that's equal. Here we have 2 moles of Na, so 2 moles of sodium. Here we have 2 moles of sodium. And on the reactant side, we have 1 mole of PB lead, and here we also have 1 mole of PB lead. So that's going to be, like, this part is the balanced chemical reaction. Thank you so much for watching. Like and subscribe. There are new videos every Friday. I hope you learned how to balance chemical reactions correctly.